Section 7.5 is rational exponents and radicals. I can rewrite expressions involving radicals and rational exponents. Big idea here. We can use rational exponents to represent radicals. In a radical expression, the number under the radical sign is the radicand. The number in the crook of the radical sign is called the index, and the index gives the degree of the root. So if we have something that looks like this, okay, my x here is my radicand, and my 5 is my index, and that tells me the degree of my root. So I would call this a fifth root. In example 1, we're finding roots. What is the simplified form of each expression? So here we're going to simplify these similarly to how we did them when we had like 9 raised to the 1/2 power. I'm going to break down the 125 into its prime factors. 25 times 5 gives me 125, and 5 times 5 gives me 25. So I can rewrite this as the cubed root of 5 times 5 times 5. 5 times 5 times 5. I'm looking for groups of 3 things, and here I have 3 5s. They all come out as just a group of 5s, and I have nothing left inside. So the cubed root of 125 equals 5. Okay, 5 is a thing I would have to take times itself 3 times to get to 125. Same idea here with b. I'm going to take 4 times 4, just 2 times 2, and 2 times 2. So when I rewrite this, I have the fourth root of 2 times 2 times 2 times 2. I'm looking for groups of 4 things. Here I have 4 2's, so they come out as just a group of 2's. So the fourth root of 16 is going to give me 2. Feel free to pause here and give these a try if you'd like. We have the cubed root of 27. 27 is 9 times 3, and 9 is 3 times 3. So when I rewrite this, I can rewrite 27 as 3 times 3 times 3. I'm looking for groups of 3 things. I have 3 3's here, so that group comes out as a 3. So the cubed root of 27 equals 3. Same idea here for b. Here I can take 16 times 2, 4 times 4, 2 times 2, 2 times 2. It doesn't matter how we break down 32, as long as it multiplies back to 32, 2, 4, 8, 16, 32, perfect. And it's all the way simplified. So here, I have 2 times itself 5 times. I'm looking for a group of 5 things, so I take out that group of 2's as just a group of 2's. So it's just a 2. 2 times itself 5 times is what gives me 32. 64 here, 8 times 8, 4 times 2, and 2 times 2. 8 is 4 times 2, and 4 is 2 times 2. So the cubed root of 64 is going to give me 2 times 2 times 2 times 2 times 2 times 2. Okay, if I look here, 1, 2, 3, 4, 5, 6. I'm looking for groups of 3 things. Here I have a group of 2's. It comes out as a 2. Here I have a group of 2's. It comes out as a 2. And because we're multiplying inside my radical, we're multiplying on the outside. So here the cubed root of 64 is going to equal 2 times 2, or 4. D here, 36 is 6 times 6, so 2 times 3, and 2 times 3. My index is a 2 here. With that, we don't have to write the 2 there. we know that it's a 2 if there isn't one written, the same way as we know that x has a 1 coefficient and a 1 exponent and is being added by 0. All of that we know even though it's not written there. And the same can be said about our exponent or our index here on a square root. We know it's a 2 even without writing it that way. So here I'm going to write it as the square root of 2 times 2 times 3 times 3. And I just put them in numerical order to help me see my groups a little bit better. You certainly don't have to, but I think it's helpful. And again, we're looking for groups of 2's. So I'm going to take out a group of 2's as a 2 and a group of 3's as a 3. I multiply those together, so the square root of 36 is just 6. Take note, on page 449 talks about radical and rational exponents. So here we just have a bunch of different ways of rewriting the exact same thing. In all of these, our base and our radicands, base and radicands are the same. In all of these, we take the numerator of our exponent, 1. Here it's not written, so we know it's a 1, m, and m. Okay, it's already up higher than our denominator. The numerator is above our denominator, so we keep that value raised up as an exponent. It's already raised higher as an exponent, so we keep it higher in our fraction in our rational exponent. And the denominator is our index. Here we would say like 1 over n or 1 nth power. Here we would say the nth root. So we'd say like 1/4 fourth root. So since that's the number that we use to label our values, we're going to do the same thing here and keep those together. So here it could be like 1/6 sixth root, for example. One other thing to look at here, it does not matter whether we have our exponent on the inside of our radical or the outside, we're going to get the same thing. I'm kind of partial to this one. I'd rather simplify first and then raise it to the power, but if you prefer to do it the other way, that's totally okay. So here, when we're looking, the only thing that gets the exponent here is a. If the 12 was supposed to have that exponent, guys, it would have to be in parentheses. The 2/3 is only touching a, so a is the only thing that gets that exponent, which means we bring our 12 down just as it is, times my base becomes my radicand. My numerator is already higher than my denominator, so I keep it raised up as an exponent. I say 2/3 here, and I say the cubed root. So I use that number to help label, it becomes my index. The denominator of my rational exponent becomes my index. Same idea here in B. I'm going to take my base. I have the 4/5 power, which means I'm going to have a 5th root. And then it's raised up in my numerator to be a 4 there. I'm going to keep it raised as an exponent as a 4 here. And again, it doesn't matter if we put that inside or parentheses or out. I'm just personally partial to having it on the outside. Doesn't matter. But I like to reduce things first, so we're dealing with smaller numbers and then take them to the power needed. So here, anytime we have a root with a number, we want to try and simplify. So 64, I'm going to break down. And we've done this one already today. So I have the 5th root of 2 times 2 times 2, a total of 6 of them, a, and this entire thing is still taken to the 4th power. Now, I'm looking for groups of 5 things. So if I count my 2's here, I have a group of 5 2's. That comes out. So I have a group of 2's on the outside, and whatever I haven't used stays inside my radical. And remember, this entire thing is still raised to that exponent. Now I just have a power to a power, and when I have a power to a power, I can take that exponent to everything inside. Instead of having a 4 on the outside, I can take 2 to the 4th, 2 to the 4th, and a to the 4th. Again, product to a power, we take that power to every piece of our product, every factor, as a power. Here, 2 to the 4th power is 16. Fifth root, 2 to the 4th power, again is 16, a to the 4th power. And that is my simplified form, and in radical form. In radical form, we want to have the radical symbols. Here I'm going to write each exponential expression in radical form. So radical form, again, means we're going to have the radical symbol. I take my base as my radicand inside my root. My numerator is what it's raised to. It's already up higher, so we keep it up higher. And here I say 5/6. I use this as my label, so I put it in my index so it can be the 6th root. And this is what I get there. For B, my exponent is only on my x here. Remember when we were talking about multiplying powers of the same base, dividing powers of the same base, things like that? We said that 5 and x to the 1/3 are their own factors. They're independent. Same idea here. So we can keep our 5 independent of that exponential factor there. So I take my base. I can raise it to the 1st power, but we don't need that 1st power. We know that it's a 1. What I do need, though, is for my denominator to become my index. And there we go, 5 times the cubed root of x. In C here, first thing I'm going to do is switch it to radical form. I'm going to keep my base as my radicand. I'm going to give my denominator as my index. And then I'm going to raise the entire thing to my numerator. And again, it's higher than my 3 in my denominator, so I keep it higher, keep it raised as that exponent. I'm going to break this down if I can. 9 times 6, which is 3 times 3, and 2 times 3. So what I really have here is the cubed root of 2 times 3 times 3 times 3 times y. And don't forget, it's still squared, raised to the 2nd power. I'm looking for groups of 3, so I take this group of 3 out of my radical. And everything that I still have inside stays inside. And then don't forget, it's still squared. So I'm going to take that exponent, instead of having it on the outside, I'm going to take it into my product by giving every single factor that exponent. So here I'm going to have 3 squared, 9. I'm still going to have the cubed root of 2 squared, 4, y squared. And that is the simplified form of my exponential function here, but in radical form. Big thing to remember here is that we need to still have our index number there. A cubed root is very different than a square root, and we want to make sure that we have that value there. That's all I'm going to be able to fit on this video. I will stop here and start another one.